The IBM 3270 is a class of block-oriented computer terminal introduced by IBM in 1971, normally used to communicate with IBM mainframes. The 3270 was the successor to the IBM 2260 display terminal. Due to the text color on the original models, these terminals are informally known as green screen terminals. Unlike a character-oriented terminal, the 3270 minimizes the number of I/O interrupts required by transferring large blocks of data known as data streams, and uses a high-speed proprietary communications interface, using coaxial cable. Although IBM no longer manufactures 3270 terminals, the IBM 3270 protocol is still commonly used via terminal emulation to access mainframe-based applications. Accordingly, such applications are sometimes referred to as green screen applications. The use of 3270 is slowly diminishing as more and more mainframe applications acquire web interfaces, although some web applications merely use the technique of screen scraping to capture old screens and transfer the data to modern front ends. Principles: the 3270 series was designed to connect with mainframe computers, often at a remote location, using the technology then available in the early 1970s. Two of the major design goals of 3270s are minimizing the amount of data transmitted, and minimizing the frequency of interrupts to the mainframe. 3270 devices are clustered, with one or more displays or printers connected to a control unit. Originally, devices were connected to the control unit over coaxial cable. Later, token ring, twisted pair, or Ethernet connections were available. A local control unit attaches directly to the channel of a nearby mainframe. A remote control unit is connected to a communications line by a modem. Remote 3270 controllers are frequently multi-dropped, with multiple control units on a line. In a data stream, both text and control are interspersed, allowing an entire screen to be painted as a single output operation. The concept of formatting in these devices allows the screen to be divided into clusters of contiguous character cells for which numerous attributes can be set. An attribute occupies a physical location on the screen that also determines the beginning and end of a field. Using a technique known as read-modified, a single transmission back to the mainframe can contain the changes from any number of formatted fields that have been modified, but without sending any unmodified fields or static data. This technique enhances the terminal throughput of the CPU, and minimizes the data transmitted. Some users familiar with character interrupt-driven terminal interfaces find this technique unusual. There is also a read buffer capability that transfers the entire content of the 3270 screen buffer, including field attributes. This is mainly used for debugging purposes to preserve the application program screen contents while replacing it, temporarily, with debugging information. Early 3270s offered three types of keyboards. The typewriter keyboard came in both a 66-key version, with no programmed function keys, and a 78-key version with 12. Both versions had two program attention keys. The data entry keyboard had 5 PF keys and 2 PA keys. The operator console keyboard had 12 PF keys and 2 PA keys. Later 3270s had 24 PF keys and 3 PA keys. When one of these keys is pressed, it will cause its control unit to generate an I/O interrupt to the host computer and present a special code identifying which key was pressed. Application program functions such as termination, page up, page down, or help can be invoked by a single key press, thereby reducing the load on very busy processors. In this way, the CPU is not interrupted at every keystroke, a scheme that allowed an early 3033 mainframe with only 16 MB to support up to 17,500 3270 terminals under CICS. On the other hand, VI-like behavior was not possible. For the same reason, a porting of Lotus 1-2-3 to mainframes with 3279 screens did not meet with success because its programmers were not able to properly adapt the spreadsheet's user interface to a screen at a time rather than character at a time device. Applications: following its introduction, the 3270 incompatibles were by far the most commonly used terminals on IBM System/370 and successor systems. IBM and third-party software that included an interactive component took for granted the presence of 3270 terminals and provided a set of ISPF panels and supporting programs. The Program Development Facility and XEDIT editors for MVS and VM/370 respectively make extensive use of 3270 features. The modified data tag is well suited to converting formatted, structured punched card input onto the 3270 display device. With the appropriate programming, any batch program that uses formatted, structured card input can be layered onto a 3270 terminal. IBM's Office Vision office productivity software enjoyed great success with 3270 interaction because of his design understanding. And for many years the Prof's calendar was the most commonly displayed screen on Office terminals around the world. Imperial Chemical Industries Man Division's Works Records system, the first known shared public spreadsheet, used the 3270 successfully for what was, in effect, a high-powered version of today's spreadsheets with additional functions. It remained in continual use for 27 years up until 2001 and, despite its lack of a GUI, cells can be defined anywhere on the screen and can be instantly reconfigured for length, content and formulas as required. It is interesting to note that ICI's online, fully interactive system predated PC spreadsheets by quite a few years and allows multiple users to use the spreadsheets at the same time, similar to today's web-based shared spreadsheets. A version of the WordPerfect word processor ported to System/370 was designed for the 3270 architecture. 3270 and the web are similar in that both follow a thin client-server architecture whereby they, the clients, are given primary responsibility for managing presentation and user input. This minimizes host interactions while still facilitating server-based information retrieval and processing. With the arrival of the web, application development has in many ways returned to the 3270 approach. In the 3270 era, all application functionality was provided centrally. With the advent of the PC, the idea was to invoke central systems only when absolutely unavoidable, and to do all application processing with local software on the personal computer. Now in the web era, the application again is strongly centrally controlled, with only technical functionality distributed to the PC. In the early 1990s, a popular solution to link PCs with the mainframes was the Irma Board, an expansion card that plugged into a PC and connected to the controller through a coaxial cable. Irma also allows file transfers between the PC and the mainframe. Third parties, one of the first groups to write and provide an operating system for the 3270 and its early predecessors was the University of Michigan, who created the Michigan Terminal System in order for the hardware to be useful outside of the manufacturer. MTS was the default OS for many years, and was still used at Michigan well into the 1990s. Many manufacturers, such as Hewlett-Packard, Memorex, ITT Courier and Teletype AT&T created 3270-compatible terminals, or adapted ASCII terminals such as the HP 2640 series to have a similar block mode capability that would transmit a screen at a time, with some form validation capability. Modern applications are sometimes built upon legacy 3270 applications, using software utilities to capture screens and transfer the data to web pages or GUI interfaces. Models: the IBM 3270 display terminal subsystem consisted of displays, printers and controllers. Optional features for the 3275 and 3277 were the selector pen or light pen, ASCII rather than OCTIC character set, an audible alarm, and a lock for the keyboard. A keyboard numeric lock was available, would lock the keyboard if the operator attempted to enter non-numeric data into a field defined as numeric. Later an operator identification card reader was added which could read information encoded on a magnetic stripe card. Displays 3277 Model 1, 40A, 12 terminal, 3277 Model 2, 80A, 24 terminal, the biggest success of all, 3277 Model 3, 80A, 32 terminal, 3277GA, a 3277 with an RS-232 CIO, often used to drive a Tektronix 4013 or 4015 graphics screen, 3278 models 1 a Euro 5, next generation, with accented characters and dead keys in countries that needed them, Model 1, 80x12, Model 2, 80A, 24, Model 3, 80A, 32 or 80x24, Model 4, 80A, 43 or 80x24, Model 5, 132A, 27 or 80A, 24. 3278 picoseconds, programmable characters. Able to display monochrome graphics, 3279, color terminal, 4-color or 7-color version, 3290, a large, amber monochrome plasma display unit, capable of displaying in various modes, including 4 independent 3278 Model 2 terminals, or a single 160A, 62 terminal. It also supported partitioning. 3178, lower cost terminal, 3179, low cost color terminal, 3104, low cost a loop connected terminal for the IBM 8100 system, 3472 info window. Generally, 3277 models were uppercase only, except for the mixed IBDIC APL or text keyboards, which had lowercase capability and possibility of dead keys. At first a simple PQ was only added in 3278 and 3279 models. A version of the IBM PC called the 3270 PC, released in October 1983, included 3270 terminal emulation. Later, the 3270 PCG and 3270 PCGX followed. Display controller 3275 remote display with controller function, 3276 remote display with controller function. Printers 3284 matrix printer, 3286 matrix printer, 3287 printer, including a color model, 3288 line printer, 3268-1, a loop-connected standalone printer for the IBM 8100 system. Controllers 3271 remote controller, 3272 local controller, 3274 cluster controller, 3174 cluster controller. By 1994 the 3174 establishment controller supported features such as attachment to multiple hosts via token ring, Ethernet, or X25 in addition to the standard channel attach or SDLC, and terminal attachment via twisted pair, token ring or Ethernet in addition to coax. They also supported attachment of asynchronous ASCII terminals, printers, and plotters alongside 3270 devices. Manufacture: the IBM 3270 display terminal subsystem was designed and developed by IBM's Kingston, New York, laboratory. The printers were developed by the Endicott, New York, laboratory. As the subsystem expanded, the 3276 display controller was developed by the Fujisawa, Japan, laboratory, and later the Yamato laboratory. And the 3279 color display and 3287 color printer by the Hursley, UK, laboratory. The subsystem products were manufactured in Kingston, Endicott, and Greenock, Scotland, UK, and shipped to users in US and worldwide. 3278 terminals continued to be manufactured in Hortolandia, near Campinas, Brazil as far as late 1980s, having its internals redesigned by a local engineering team using modern CMOS technology, while retaining its external look and feel. Telnet 3270, Telnet 3270, or TN3270 describes both the process of sending and receiving 3270 data streams using the Telnet protocol and the software that emulates a 3270 class terminal that communicates using that process. TN3270 allows a 3270 terminal emulator to communicate over a TCP/IP network instead of an SNA network. Telnet 3270 can be used for either terminal or print connections. Standard Telnet clients cannot be used as a substitute for TN3270 clients, as they use fundamentally different techniques for exchanging data. Technical information 3270 character set equals. The following table shows the 32,753,284/3286 character set for U.S. English IBDIC. lowercase characters display or printers uppercase. NL, M, DUP, and FM control characters display and printers 5, 9, and characters, respectively, except by the printer when WCC or CCC bits 2 and 3 equals OOB, in which case NL and M serve their control function and do not print. Optional characters were available for US ASCII, and UK, French, German, and Italian ABCDIC. Data stream data sent to the 3270 consists of commands and orders. Commands instruct the 3270 control unit to perform some action on a specified device, such as read or write. Orders are sent as part of the data stream to control the format of the device buffer. The following description applies to the 3271, 3272, and 3275 control units. Later models of 3270 have additional capabilities. Commands write control character the data sent by write or erase write consists of the command code itself followed by a write control character optionally followed by a buffer containing orders or data. The WCC controls the operation of the device. Bits may start printer operation and specify a print format. Other bit settings will sound the audible alarm if installed, unlock the keyboard to allow operator entry, or reset all the modified data tags in the device buffer. Orders consist of the order code byte followed by 0 to 3 bytes of variable information. Attributes the original 3277 and 3275 displays used an 8-bit attribute byte of which 5 bits were used. Bit 0 and 1 are set so that the attribute will always be a valid ABCDIC character. Bit 2 was 0 to indicate that the associated field is unprotected or 1 for protected. Bit 3 was 0 to indicate that this field, if unprotected, could accept alphanumeric input. 1 indicates that only numeric input was accepted, and would automatically shift to numeric for some keyboards. Bit 4 and 5 operate in tandem. OOB indicate that the field is displayed on the screen and is not select-append detectable. O1B indicates that the field is displayable and select-append detectable. 10B indicates that the field is intensified, displayable, and select-append detectable. 11B indicates that the field is non-display, non-printable, and not pen detectable. This last could be used in conjunction with the modified data tag to embed static data on the screen that would be read each time data was read from the device. Bit 7 is the modified data tag, where 0 indicates that the associated field has not been modified by the operator and 1 indicates that it has been modified. As noted above, this bit could be set programmatically to cause the field to be treated as modified. Later models included base color support for 4 colors. In base color mode, the protection and intensity bits are used in combination to select among 4 colors, normally white, red, blue, and green. The protection bits retain their protection functions as well as determining color. Still later models used extended attributes to add support for 7 colors, blinking, reverse video, underscoring, field outlining, field validation, and programmed symbols. Buffer addressing 3270 displays and printers had a buffer containing 1 byte for every screen position. For example, a 3277 Model 2 featured a screen size of 24 rows of 80 columns for a buffer size of 1920 bytes. Bytes were addressed from 0 to the screen size -1, in this example 1919. There is a fixed relationship between each buffer storage location and its position on the display screen. Most orders started operation at the current buffer address, and executing an order or writing data would update this address. The buffer address could be set directly using the set buffer address order, often followed by start field. For a device with a 1920 character display, a 12-bit address was sufficient. Later 3270s with larger screen sizes used 14 or 16 bits. Addresses were encoded in orders in 2 bytes. For 12-bit addresses, the high-order 2 bits of each byte were normally set to form valid ABCDIC characters. For example, address 0 was coded as X4040, or space, address 1919 was coded as X5D7F, or programmers' hand-coding panels usually kept the table of addresses from the 3270 component description or the 3270 reference card handy. Example equals, the following data stream writes an attribute in row 24, column 1, writes the characters in row 24, columns 2 and 3, and creates an unprotected field on row 24 from columns 5 to 79. Because the buffer wraps around an attribute is placed on row 24, column 80 to terminate the input field. This data stream would normally be written using an erase write command which would set undefined positions on the screen to 00x. Values are given in hexadecimal. Data description, D3WCC, reset device plus restore keyboard plus reset MDT, 11.5 CFOSBA row 24 column 1, 1DFOSF attribute, protected, alphanumeric, display normal intensity, not pen detectable, MDT off, 6E40, 1D40 SF attribute, unprotected, alphanumeric, display normal intensity, not pen detectable, MDT off, SBA is not required here since this is being written at the current buffer position, 13IC, cursor displays at current position, row 24, column 5, 11.5D7F SBA row 24 column 80, 1DFO. SF attribute, protected, alphanumeric, display normal intensity, not pen detectable, MDT off. See also, 3270 emulator, list of IBM products, IBM 5250 display terminal subsystem for IBM AS/400. Notes. References. External links, 3270 data stream programming, Rabanvi/3270 font, a TTF remake of the font from the 3270. This article is based on material taken from the free online Dictionary of Computing prior to November 1, 2008 and incorporated under the relicensing terms of the GFDL, version 1.3 or later.